So in this video, we're going to be looking at L'Hopital's rule for quotient and product indeterminate forms. So what are these quotient and product indeterminate forms? Well, we're looking for expressions of the form 0 over 0, or plus minus infinity over plus minus infinity, and these are obviously our quotient indeterminate forms. And for our product indeterminate forms, we're looking for expressions 0 times plus minus infinity, and these are product indeterminate forms. So what does L'Hopital's rule actually say? So suppose either that we have the limit as x approaches a of f of x over g of x is equal to 0 of 0, or that this limit is equal to plus minus infinity over plus minus infinity, where a is any real number. Then L'Hopital's rule says that the limit of f of x over g of x as x approaches a is equal to the limit as x approaches a of f prime of x over g prime of x. So here, what we're doing is we're finding the limit by differentiating the numerator and the denominator. So let's look at an example. Say we want to find the limit as x approaches 0 of sine x over x. And these are examples of quotient indeterminate forms. So if we find this limit, just plugging in 0, we're going to get that this limit is going to equal to 0 over 0, which is one of our indeterminate forms. Now, if we use L'Hopital's rule, we find that this limit is equal to the limit as x approaches 0. Differentiating the numerator, we get cos x, and differentiating the denominator, we get 1. Now, plugging in 0, we actually find that this limit is equal to 1, as opposed to this weird indeterminate form we got before. So let's look at another example of a quotient indeterminate form. So say now we want to find the limit of e to the x over x cubed as x goes to infinity. Just plugging in infinity, we're going to find that this limit is going to be equal to infinity over infinity, which is an indeterminate quotient form. Now, if we use L'Hopital's rule, we find that this limit is equal to the limit as x approaches infinity over e to the x over 3x squared, differentiating the numerator and the denominator. But this is also an indeterminate form of infinity over infinity. So we can actually use L'Hopital's rule again. So now we get that this limit is equal to the limit as x goes to infinity of e to the x over 6x. But this is again an indeterminate quotient form of infinity over infinity. So once more we use L'Hopital's rule and find that this limit is equal to the limit as x goes to infinity of e to the x over 6, which is actually just infinity. And now we've solved this limit with L'Hopital's rule, where at first we get some indeterminate form, and then we end up with a non-indeterminate form solution using L'Hopital's rule. So our final solution is the limit is infinity. Let's look at an example of a product indeterminate form. So say we want to find the limit as x approaches 0 from the positive side of x times ln of x. Well, if we just plug in 0 into this expression, we're going to find that this limit will be equal to 0 times minus infinity, which is an indeterminate form. Now, it's important to remember here that if we have a function f of x times g of x, this is equal to g of x over 1 over f of x, or alternatively, f of x g of x is equal to, f of x over 1 over g of x. Now we can rewrite this original limit. So now this limit is equal to the limit as x goes to 0 on the positive side of ln of x over 1 over x. Now, we can see that if we plug in 0 into this equation, we're actually going to get minus infinity over infinity, which is another indeterminate quotient form. So now we can use L'Hopital's rule once again. And find that this limit will be equal to the limit as x goes to 0 from the positive side of 1 over x, differentiating ln x, over minus 1 over x squared. And if we rearrange this, we'll find that this limit is equal to the limit as x approaches 0 from the positive side of 1 times minus x squared over x, which is equal to the limit as x goes to 0 from the positive side of minus x, which is actually 0. And now we've solved this complicated original limit with L'Hopital's rule. And that's how we approach L'Hopital's rule with quotient and product indeterminate forms.